is equal to ma. So, okay, and therefore A is equal to F over m. We are solving for the first one, and since we are yet looking at the x direction, we can write this as x and we can write this as x. So, therefore, Ax is equal to F1 over m. So, this is equal to 4 Newton divided by 0.2 kg, and this is equal to 20 meter per second square. That is for the first case. Okay. Okay. Now, for the second case, the first case, this is the first situation, we are only talking about F1. Now, we have to talk about the second case in which we have two forces F1 and F2. What happens there? So, situation B, in this case, this is B, this is A, just F1, okay. This is A, okay. So, situation B is two horizontal forces act. So, what is the resultant force, okay. So, in this case, the total force F net x is equal to F1 minus F2. Since they are in the same direction, we can write that, we can just add them as numbers, okay. So, this will be equal to max, okay. Sorry, A with a subscript of x. You understand the concept of subscript, you do not multiply it, it is written a little lower, it just to indicate something, okay. So, Ax is equal to F1 minus F2 divided by m. So, this is equal to 4 minus 2 newtons divided by 0.2 kg, and the answer is equal to 10 meter per second square. Is that clear? Okay, can you please take a picture now? Okay. Now we have to look at the third case. In the third case, there is another force. This is F3, and this force is applied at an angle of 30 degrees. Can you see it in the figure? C and F. In figure C and F, you can see a force going downwards, and this is a very small force, as it has a magnitude of 1 Newton. So, in this case, you can see this is the body, okay, and here it is experiencing a force that is very small. So, therefore, the length is very small. This is F3 is equal to 1 Newton, and the angle that it is making with the horizontal surface is theta. And in situation 3, the other force that is acting on this body is F2. This one is here, F2 is equal to 2 newtons. So, these are the forces in this case. Again, these are vectors, so we will draw the vector signs. So, Ax in this case we have to find. Again, this will be F3 x minus F2 is equal to max. Okay. So, Ax is equal to F3x minus F2 divided by m. F3x means the horizontal component of F3. So, what will be the horizontal component of F3? F3x is equal to F3x is equal to F3 cos theta. So, therefore, Ax is equal to F3 cos theta minus F2 divided by m. Now, you can put the values. This is situation number C. This, okay. So, in this case, we have Ax is equal to F3, which is 1 Newton multiplied by cos of 30 degrees minus 2 newtons, which is the value of F2 divided by the mass, which is 0.2 kg, and you get the answer. What is the answer? So, this is interesting. What do you mean by minus 5.7?
Towards F2.
Okay. Right. Okay, it's the opposite direction. But there is another thing you should know, that when acceleration is negative, it also means deceleration. In this case, the direction is opposite because F2 was the bigger vector. So, therefore, it tends to go in the side of the towards the bigger force. But in general, a negative acceleration can also mean a deceleration or a retardation. So, these are some of the terms that we use for a negative acceleration. Have you marked the attendance? Where is the attendance? Okay, now we just have 2-3 minutes, right? Just let us look at page number 100, okay? So, you can complete the rest at home, but let us discuss the concepts in this case. So, it is a long problem, but we will have to discuss the main ideas and then you can complete it. It is already solved over here, right. Okay. So, what is this? You have a table, you have a block, you have a pulley, you have a string attached, it is going over the pulley like this. And then you have another one which is down. So, what is the statement? The figure shows a block, this is figure 5.14. Okay. The figure shows a block S, the sliding block, with a mass m 3.3 kg. So, this is a block called S, it has a mass represented by 3.3 kg. Okay. You see, it is very useful when you are drawing the figure and marking all the quantities and values given, then it will be easy to understand the problem. Okay. So, the block is free to move along a horizontal frictionless surface, and देखो यहाँ पे they have ignored friction again. Most of the time it is ignored, but in some problems they will give you the value of the friction and then you include it. Okay. And there is a second block which is called H. So, this is, let me write it here, this is block S. This is block H. In this case, S for sliding. They're calling this the sliding block, the block that will slide on the surface. H for hanging. Hanging means there will be a force of gravity as well, right? When something is hanging, there is a force of gravity. And the mass of this block is given as 2.1 kg. So the mass in this case is 2.1 kg. See, this is capital M and this is small m, just to differentiate between the two. Sometimes we can use M1, M2, and in this case they have used one as capital, the bigger one as capital and the smaller one as small. Okay, the hanging block H4 falls as a sliding block, S accelerates to the right. So what is the question? Find the acceleration of block S, and B the acceleration of block H, and C the tension of the core. So this is interesting. It is using the concepts of the forces that we just studied. It's using the concept of tension. It's using the concept of gravity. It's using the concept of F is equal to ma, right? The Newton's laws. Okay. So you can go home and complete this. Okay. Beta page 100. I've written it on the board actually. You can make a photo. Make a photo please. अच्छा, अगेन आई वुड लाइक टू स्ट्रेस द पॉइंट कि जब आप कोर्स आउटलाइन पढ़े ना, वो चैप्टर वाइज नहीं लिखी हुई, वो टॉपिक वाइज लिखी हुई है, ठीक है। और जब आप बुक को देखें ना, तो आपने मैच करना द टॉपिक विद द चैप्टर्स। डोंट गेट कंफ्यूज्ड अबाउट दिस। वहाँ जो भी कुछ लिखा हुआ है वो टॉपिक वाइज लिखा हुआ है। और बुक अप्रॉक्सीमेटली मैंने चेक किया था 10 टॉपिक्स जो हैं वो हमें 13 चैप्टर्स में मिल जाते हैं। इसमें घबराने की कोई बात नहीं है, बिकॉज हम 100% सारे टॉपिक्स नहीं कर रहे हैं, हम उसमें से सेलेक्टिव टॉपिक्स कर रहे हैं, ठीक है। अच्छा, अटेंडेंस दो मुझे। ओके, सबने मार्क कर दिए? नहीं, ये रहते हैं अभी। हाँ, हो गया।